So the main use of our regression line is to predict values, but also to determine how good our model is over here. So in order to do this, you're first going to plug in x values into the linear regression equation. Now your calculator and StatCrunch can calculate the linear regression equation for you. Once we calculate that, we're going to look at the residuals, and the residuals basically tell you how far off your estimate is. How close is the actual value from the line of fit? So residual, our formula is actually right here, which is the residual using the letter E for error is equal to our actual value minus the predicted value. So this is actual minus predicted. Our actual value is a value that our measurement, the predicted value is the value we would get from our linear regression equation. So this is how we calculate the residual. And let's look at an example down here. So we have a scatter plot of the systolic blood pressure, and our systolic blood pressure is actually given in millimeter of mercury, and then the weight over here are in pounds. So generally, when I give you a question like this on the exam, I'm going to give you the units because this is important when you're answering the question. Our correlation coefficient over here is given to us, so this is our R. And we also have a scatter plot given over here, and we can see that we have a good linear model. There's no other, non-linear trend of our data. The values are pretty close to the line. There's no outlier, although there's a value maybe that's a little further away from the line. But generally, we have there's a strong positive linear relationship between our two variables over here, which is the weight and the systolic blood pressure. So the regression equation is given, and it's right down here. So our y hat is 1.1 plus 0.764 times x. So again, that is the equation of our line. And as I mentioned before, usually when we're in statistics, we mention our y-intercept first. So this is our y-intercept. And then we mention our slope, so kind of in reverse order when compared to an algebra class. Sometimes you'll see it written as like, instead of writing x and y, we could do systolic blood pressure and then put the hat over here. That's important because it tells us it's the predicted value. It's not the actual value of our points over here. We had our y-intercept at 1.1 plus 0.764 times the weight. We now can use this line to make predictions. For example, if someone weighed 200 pounds, what would be the predicted value for the systolic blood pressure? So we would simply go from 200 pounds up to our line and then over to our y-axis in order to find the predicted value. Mathematically, we would simply plug our weight in for our x value and then calculate our y hat. So in our question, we are asked to find a predicted value. So we have a person who weighs 188 pounds, and we're also given the systolic blood pressure of them, which is 136. It says predict the systolic blood pressure for a person weighing 188 pounds. So we are trying to find the predicted value, y hat, using our regression line, plugging in our x values. So with these types of questions, you're always going to plug in your x value over here, which is 188 pounds, and then you're going to calculate this. This is equal to 144.6 0.73. And over here, the units for Y, which is our systolic blood pressure, is millimeter of mercury over here. So very important when you're giving a predicted value, you need to make sure you have the units in there. Then it says find the residual for this individual. So we already said that X was 188 pounds. We had our Y value, which was 136 millimeter of mercury. And we calculated our Y hat, which was 144.73 millimeter of mercury. So in order to calculate our residual, we're going to use our formula. Is Y minus Y hat. Make sure you're doing it in that order. So actual value minus predicted value is 136 minus 144.73. And that gives us a residual of negative 8.73 millimeter of mercury. Over here, the residual has the same unit as our Y variable. So let's go up to our graph and see what's happening over here. Let me actually remove the marking here. And so our value, our X value was at 188. Our Y value was 136. So this was the dot I had highlighted down here. And when we're taking our actual value, which is this value down here, the Y value of 136, and we subtract from it the predicted value. Well, the predicted value is just a value that corresponds to it on the line, and we subtract these two, we end up with, the distance over here. And moreover, any value that is below the line will have a negative residual. Hold on, I misspelled that. And any value above the line will have a positive residual, right? If you're subtracting a value that's lower minus a value that's higher, that gives you a negative value, where the values above the line, we have a larger value minus a smaller value, gives you a positive residual. So anything below the line will have a negative residual, anything above the line, a positive residual. When we're looking at our prediction over here in our example is actually an over prediction, because our line is above our actual value, where values with a positive residual will be under predictions, because our line is actually below where it should be. So just keep that in mind. Above the line is a positive residual, but it's an under prediction. Below the line is a negative residual with an over prediction.